Hi class, today's lesson is 11-9. It's our last lesson of Unit 11, and it's about solving integer equations. You're going to recognize the type of problems we do because they're algebraic in nature, yet we're going to add the element of negative numbers. So our purpose today, as you see on the screen, is to solve equations using integers. Again, no new vocabulary. We'll be hashing out the vocabulary that we've used over the year regarding integers as well as algebraic functions and expressions. All right, these are some identity properties that we need to know. In terms of addition, the property we refer to as 0 allows us to get a number back. In other words, the sum of 0 and any number is that number. When we plug in a 6 and we add a 0, we get 6 back. In algebraic terms, using variables, we have d plus 0 gives us d. In multiplication, the identity property is slightly different. What do we do in order to get that number back? Well, we multiply it by 1. 5 times 1 equals 5. And so here we have d times 1 equals d, said algebraically. All right, here we go with the first example. It says solve 4 plus x equals negative 2. Notice what right now we see a negative integer in there. So we're going to go ahead and solve it like we would normally do. Actually, this should be second nature to you now that we've been doing algebra throughout the whole year. I'm going to rewrite the problem. 4 plus x equals negative 2. First thing we need to recognize is we need to isolate the variable. When we isolate the variable, we see that we've got to get rid of this plus 4. How do we get rid of a plus 4? We take the inverse operation. So we're going to subtract 4. Subtract 4 from both sides of the equation. 4 minus 4 is 0. That being one of the identity properties, 0 plus x just gives us x on that side. Then we have a negative 2, subtract 4. A negative 2, subtract a positive 4. When we have a negative 2, subtract a positive 4, we can go ahead and think of that as a negative 2 plus a negative 4. That's easier to understand lots of times when we add integers. Negative 2 plus a negative 4 makes it more negative, which is negative 6. Answer for this first problem, x equals negative 6. The next problem I'll drag out here is a similar problem. This time it's a different operation. Here we have y minus 6 equals negative 5. Same thing. We're going to isolate the variable, which means we're going to leave y by itself on this side of the equation. How do we get rid of a minus 6? Well, we add 6 to both sides. These drop out entirely because negative 6 plus a 6 is 0. So y equals, well, what's negative 5 plus 6? I can pretty easily do that in my head. You have a 6 and a negative 5. That gives me a 1. So y equals 1 in this case. Let's go to a couple of other examples, this time involving multiplication and division. Same principle here. We have negative 3 times a equals 15. I'm going to rewrite that over here. Now, in order to isolate the variable here, we need to get rid of a times minus 3. Or I should say a times a negative 3. How do we get rid of a times negative 3? Well, we divide each side by negative 3. Negative 3 divided by 3 gives us 1, and 1 times a, again the identity property, just gives us a plain old a, gives us that a back. Then we have 15 divided by negative 3. I see that it's a positive divided by a negative, and I know if it's a positive divided by a negative or a negative divided by a positive, we're going to get a negative quotient. 15 then divided by 3 gives me 5. The sign is correct. A equals negative 5. Let's go to the last example we have. This last example is b over negative 4 equals negative 2, or b divided by 4 divided by negative 4 equals negative 2. Isolate the variable again. How do we get rid of a divided by 4 or divided by negative 4? Well, we multiply by negative 4. So let me rewrite the problem here. We have b, kind of looks like a 6, but it's a b divided by negative 4 equals negative 2. So I'm going to go ahead and multiply both sides by negative 4 in order to get rid of the negative 4's on this side, because negative 4 divided by negative 4 is 1, and 1 times b is just a plain b. Identity property. Negative 2 times a negative 4. Here I have a negative times a negative. When I have a negative times a negative or a positive times a positive, I know I'm going to have a positive answer, a positive product. So I just now simply multiply 2 times 4, which is 8, and keep it positive. B equals 8. All right. Final thing for you to do, of course, is to complete the problem. There's two parts of this problem. It says, tell what operation you would use to solve x plus 12 equals negative 32. What operation would you use to isolate the variable? That's the question. And here's the second question. Tell whether the solution to negative 9 times t equals negative 27 will be positive or negative without actually solving the equation. So it's going to force you to look at the equation and specifically look at the integers themselves. All right, we'll see you in class.